Hello class. Today we will be going over the Math 112 written assessment. This is a common assessment that's required by all Math 112 classes, and we're going to look at a few notes on these parts. Okay, look at example 1. Example 1 says find the inverse and domain. Your function is x to the 5th power minus 4. Right here, I'm going to replace y for f of x. After that, I want to interchange my x and y variables. So if you notice here, where y is, I wrote x. Where x is, I plugged in y. From here, I want to solve for y. But before I solve for y, I want to rearrange my equation. So what I did was I placed the y to the 5th minus 4 to the left side and x on the right. I want to isolate y to the 5th as much as possible. So the first step is to add 4 to the right side. To get rid of that 5, I'm going to take the 5th root. So once I take the 5th root on both sides, the 5's over here will go away, and I'm left with y equals the 5th root of x plus 4. I want to now substitute my inverse for y. And this is my inverse function. To find the domain, when I see a denominator, then I know I have to worry about undefined answers. But I do not have a denominator here, so that won't be a problem. When I see my roots, it does pose a problem because sometimes I have imaginary numbers. But imaginary numbers, that will only apply with my even numbers. So since this is an odd index, odd root, I don't have to worry about my imaginary numbers because I can have a negative sign underneath a odd root. So my domain will be negative infinity to positive infinity. I can also check GeoGebra, Desmos, or use my graphing calculator to graph this function, and I will see that the function from my left to right is going from negative infinity to positive infinity. Example 2, you can find in your textbook. And the direction is telling you to solve for x, basically. This is my problem that I copied from the book. If you notice on the first step, I just rearranged the equation on the left side only. So if you notice on the left-hand side, I wrote my plus 4 to the back. I brought the negative down, and I put the plus 4 towards the back. My goal is to get the log 3 minus x isolate as much as possible. So to achieve that, I have to subtract 4 on both sides of my equation. The 4's cancel to 0. 3 minus 4 is negative 1, and I bring my negative sign down. Now, I have to get rid of that negative sign, so it's understood to be a negative 1. We want to divide negative 1 on both sides of our equations. And I know a negative divided by negative makes a positive. One thing you want to remember is that if I do not see a number in my base area, that's understood to be 10. So this is understood to be a base 10 number. From here, I can rewrite this problem in exponential form. So if you go back to page 344 in your textbooks, it shows you how to convert it from logarithmic form to exponential form. So if you notice, a is 10. X is the 3 minus x, and then y is 1. And all I did was I substituted those parts into my exponential formula. So I have 3 minus x equal 10 to the 1 power, and we got all that information from up here. And then we just solve for x like a regular equation. Again, you know this is understood to be a positive x. So to move it to the right, it becomes minus x. I have negative x equals 10 minus 3, which is positive 7. Divide both sides by negative 1. So 7 divided by negative 1 equals negative 7. So x is negative 7. Now, if I plug in negative 7 back into my original logarithmic equation, it will give me 3 again. So I plug in my negative 7 where x is here. And remember, you're going to say 3 negative times negative is plus. So it'll be 3 plus 7. On my calculator, it should equal negative 3. Okay, look at example 3. Example 3. It has a lot of information in this one, but you will need this for the assessment. So you want to make sure you understand every step that we're talking about. So for example 3, I have my polynomial of x to the third plus 2x squared plus 5x plus 4. Now, some vocabulary that you need to know is I know that my leading coefficient is 1. My degree is 3. That means I should have 3 answers here. Whether they're negative numbers, positive numbers, or complex numbers. We know complex numbers are the imaginary numbers. So it should be 3 answers for x. And then my constant term is 4. So the first step is list all possible rational zeros. My formula is P over Q. P is your constant term, which we said was 4. Q is your leading coefficient, which is 1. And I want you to remember that your leading coefficient is always connected with the degree. So basically, I'm trying to find all my factors for 4. When you think about that, you want to think about everything that I can multiply to get 4. So I know 1 times 4, 2 times 2, 4 times 1. So those are all the factors for 4. 1, 2, and 4. But I also want to include my positive and negative signs because I can say negative 2 times negative 2 is positive 4, right? So we do want to include plus or minus. All my factors for 1, positive, negative 1, because the only thing I can say is 1 times 1. So my possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 4, and that's my answer for that first step. My actual zeros, though, multiple ways you can do this. You can graph this equation, and you can tell me where does it cross the x-axis. Wherever it crosses the x-axis, that's my actual zero. So if you just input this equation, you'll see that the only place it crosses the x-axis is at negative 1. Okay? Now, another way you can do it is you have to work it out on your calculator, work it out by hand. So the way you will work it out is you have to take positive 1 and plug it in for x. Negative 1, plug it in for x. Plus or minus 2, plus or minus 4. So you have to test all 6 of these terms for x and see which answer will equal to 0. If it does not equal 0, it is not a possible 0. If it does equal 0, it is a actual 0. So the only one that worked was negative 1, and I showed you how I plugged it in, and then you can work it out or type it in, and you should get 0. Now, another piece of information. We want to find out what the number of possible real zeros are. Now, the easiest way to look at this is to look at your answers. You can really work backwards and see what it will be. I can already tell you that my degree is 3, so I'm supposed to have 3 answers. But if you notice, only 1 answer worked, and it's a negative. So I can tell you just by working backwards that I have 1 negative real zero. And I don't have any positive real zeros. That means I have 2 complex roots. So my answer for all of this part, this next part, would be 1 negative real zero and 2 complex roots. But I'm gonna show you how to do the process just in case you don't know this step. So to find the number of positive real zeros, and it's not hard, you're just counting. The question I said was, how many times does a positive negative sign change? So if I look at my sign, I got positive to positive, nothing changed. Positive, positive, nothing changed. Positive, positive, nothing changed. So nothing changed. So since nothing changed, there are no positive real zeros. Now let's check the negative real zeros. So for my negative real zeros, I do have to do a little work for this one. I have to substitute x with negative x. So everywhere I saw an x, I'm plugging in negative x. Now, when I do the math, I know that a negative and an odd exponent will always be negative. A negative and an even exponent will always be positive. And then a negative, again, with an odd exponent will always be negative. So if it's odd, it's going to be negative. If it's even, it's going to be positive. So now I count how many times did my sign change. Right here, I went from negative to positive. That's one change. Then from here, positive, negative, that's a second change. And then from a negative to a positive, that's a third change. So there are 3 sign changes. So one of my possibility can be 3 negative real zeros. But you do have to do an extra step. And this procedure here, you also have to apply to the positive real numbers. But the only reason we didn't apply this part is because we had no positive real numbers. But if your positive numbers had sign changes, you would have to do the same counting technique. Okay, so here, we want another way you have to look for this answer is you have to identify your even number, which is 2, and then you subtract. So if I look at my given information, my even integer was 2. So I have to take the original answer I have, which is 3, and subtract by my even exponent. So 3 minus 2 will give me 1. So either there are 3 or 1 negative real zeros. So let's go over that one more time real quick. I had 3 sign changes. So that's how I got 3. Then I take that answer, which was 3, subtract it by my even exponent to get 1. Now, I want to find my number of complex roots. So right here, you have to apply to your mental math skills. So if I go back to my original problem, again, I know that my degree was 3. That means I should have 3 answers. Now, I already know that by looking at this answer, it can be 3 negative real zeros, or it can be 1 because I have no positives. So we're not looking at that. So I can have 3 or 1 negative real numbers. So since I have a degree of 3, there are 2 or 0 complex roots. And the reason why, because if I have 3 negative real zeros, that means I have no complex numbers. Because again, my degree is 3. So 3 minus 3 give me 0. But if I have only 1 negative real zero, that means that 3 minus 1 will give me 2 complex roots. But from the previous answers, we already know that we have only 1 negative real zero. So because we have only 1 negative real zero, it's going to be 2 complex roots. So, but for our answer, we want to say we only have 2 or 0. Now, for example 4, you need to review your transformation rules from your online notes on Blackboard and look at section 2.6. Based on this example, all you're going to do is you're going to identify what the transformation will be, and then you will sketch that graph. So if it tells you to shift 1 or reflect on the x-axis, you're just going to take the actual graph, which is your parent function, and you're going to redraw it based off what the transformation tells you to do. So if I have a parabola and it tells me to shift it to the right 1, I shift to the right 1. If it says reflect on the x-axis, that means I'm going to take the parabola and flip it upside down, and I'm going to draw the new graph. So that's basically what that example is going to tell you to do, is just look at what it tells you to do and regraph it. So just pay attention to how to graph the new transformations. Okay, you all studied and do well on your exam.